All right, day 2, moving through this fun and exciting unit of arithmetic and geometric sequences and series. We get to day 2 is all about arithmetic sequences and series and partial sums. I'm going to fly through these notes because I think it is a lot of review for you guys. So there's going to be a lot of examples where I'm going to say, all right, try this one, pause your video, try this one, hit play when you're ready to come back. Okay, so hopefully I'm going to try and keep this video nice and short, but as you know, I like to talk, so maybe it won't be nice and short after all. All right, anyways, let's get started. We have a sequence is arithmetic if you have a consecutive difference between, or sorry, a consistent difference between each term. So for example, 7 minus 5n is arithmetic, but n squared would not give you an arithmetic sequence. 1/4 times the sum of n plus 3, that would give you an arithmetic sequence. So if you are adding or subtracting the same number every time from one term to the next, you're going to end up with an arithmetic sequence. So what I want you to do for this first term is I want you to find, all you need is 2 terms because I told you which ones were arithmetic. So you don't have to worry about doing number 2. Let's get a pen here. All right, so you don't have to, or sorry, B. You don't have to worry about doing B. But we're going to find the common differences for part A and part C. So what I want you to do is find the first 2 terms and then just find the common difference. Okay, so if you take a look in part A, the first term was 2, the second one was -3, giving you a common difference of -5. In order to get from 2 to -3, I have to subtract 5. In part C, the first term was 1 and the second term was 5/4. So in order to get from 1 to 5/4, we got to add a fourth to that. All right, sorry, I was reading something at the same time I was talking. I really shouldn't try and do that. Okay, all right, moving on. So this next blue box just kind of gives you some information about the formulas that we're going to use. So there's 2 different formulas that you can see there. You can use the first one, which is D, your common difference, times N, whichever term you're looking for, plus C. If you'll notice, that is your linear y equals mx plus b, very similar to that. And then you have one for recursion. Okay, so the second one would use the term before it in order to find the next term. So this next one says find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So what that means is that your D is 3 and the first term, so A sub 1, is 2. So you're going to go ahead and you're going to use this formula here. So A sub n equals D times n plus C. And the first thing that I want you to do is to substitute in for things that you know. So for example, if you know that A sub 1, that would be your D value times 1 plus C. We know A sub 1 is 2. We know our common difference is 3. This allows us now to solve for C. So we have a C value of -1. Now, once you have your C value and your D value, you can write the general form. So this would be A sub n equals 3n minus 1. You now could go ahead and find any term in the sequence. If I asked you to find the 792nd term in the sequence, you could do that because you now have the general formula. All right, this next question gets a little bit trickier because they gave us the 4th term and the 13th term, and they want you to write the first 11 terms in the sequence. So you got to think here, you're looking at the 4th term and the 13th term of the sequence. So what we want to do is we want to find out what the common difference is between each term. So what I'm going to do is I'm going to say, all right, well, if I take 65 minus 20. So I took the 13th term minus the 4th term. So I'm taking the 13th term minus the 4th term. Okay, and that would give me 45 over 9, which is going to give me a common difference of 5. So if you want to find the common difference when you're given 2 random points, subtract the value of those 2 terms and then the number in which they fall in the sequence, in this case the 13th and the 4th. Now this gives us our common difference. Okay, so we have a common difference of 5. Now, I can use either the 4th term or the 13th term in order to find my C value, just like we did in the first example. So what I want you to do now is use your formula, refer back to the example before if you need to, and I want you to find the general form for this sequence. Okay, to come up with 5n for your general formula. Okay, I use the fourth term. If you use the 13th term, you still should have come up with the same general form. The next thing, so now if you were to just list out the first 11 terms, basically you're going to just count by fives. So 5, 10, 15, 20, all the way up to 55 would give you the first 11 terms. If you were going to write this as a recursive formula, though, so if I'm looking at the recursion of it, if I want to find a term, so let's say we'll use n plus 1, I'm going to take the term before it. So that would be referred to as a sub n, and then I would just add 5 because the pattern is 5, 10, 15, 20. So you're just adding 5 every time you go from one term to the next. So if you were going to do it the recursion form, you would always have to know the term before it in order to get to the next term. All right, this next one. You're going to find the 9th term of the arithmetic sequence, and the arithmetic sequence is going to start off with a 2 and then a 9. So see if you can find the general form for that. All right, so you should have come up with the general form of 7n minus 5. So that would give you the general form for your sequence. And then finding the 9th term should have gotten you 58. Okay, now the next one says find the first term of the arithmetic sequence whose 7th term is 4 and 16th term is 40. So I want you to refer back to the question at the top of this page where it says the 4th term. It's the same process. So you're going to go through the same process of finding the common difference, then write the general form, and then you're going to find the first term of the sequence in this case. All right, how'd you do on that one? Okay, you'll notice on this one, I'm going to show you two different ways to find the common difference. The first thing I did was like we did in the 2 problems ago. The second thing I did was looking at it a little bit differently. I said if I take the 16th term, what I'm really doing is I'm taking the 7th term and I'm using the common difference 9 times. So I said the 16th term is equal to the 7th term plus 9 times the common difference. And so that's another way that you can find your common difference. So either way you want to use is going to work for you. All right, I came up with a C value of negative 24, gave me a general form of 4D minus 24, which gave me a first term in this sequence of negative 20. And then off to the side, I just put the recursion form. So I would always have to take the term before and add 4 in order to get to the next term. All right, let's move on to sums. So if I want to take the sum of a finite arithmetic sequence, that means that I have a specific number of terms that I am looking to add together. The formula, and remember you get a formula sheet on your quest, the formula for the sum here, you take however many terms you're adding together, divide it by 2, and then multiply that by the sum of the first term, and then this a sub n is the last term in that sequence. So this first one says find the sum of those numbers. Now we're not going to do 1 plus 3 is 4 plus 5 is 9. Okay, we're going to actually use the formula. So in this case, we need to know how many terms we're adding together. This happens to be 10 terms that we're going to add together. So this would be 10 divided by 2. And then you're going to put the first term plus the last term. So 1 plus 19. So that's going to be 5 times 20. So then the sum of these 10 terms is 100. Okay, so again, if you want to go through and take the time and add all 10 of those terms together to double check us, you should get 100. Now that last one you might have been able to add pretty quickly, but this next one not so much. So we're going to find the sum of the integers from 1 to 100. So you're looking for the sum of 100 numbers, 1, 2, 3, 4. So you're going to add all those up. So I want you to go ahead and I'm going to write down the formula for you again. So S sub n equals n divided by 2 times the sum of a sub 1 plus a sub n. Okay, so I want you to go ahead and find the sum of that sequence. Okay, did you get 5,050? Hope so. All right, this next one, it says find the sum of integers from 1 to n. So n is the last term, so this one's just going to be a basic formula. So you're going to say the sum of the integers, we don't know how many integers there are, so we can just leave it as a general lowercase n, but it would be n divided by 2, okay, and then your sum would be 1 plus n. Okay, so This just being a general form, if you're going from 1 to n, you don't know how many integers there happens to be. Okay. Okay, this one, remember we talked about partial sums last video, and I said that the partial sum of an infinite sequence, they may say, we'll just add up this many numbers, okay? So this one is the 150th partial sum. So you're going to add 150 numbers together. So your n value is going to be 150. But before you can do that, remember, in order to use the sum formula, you need to know the last term of the sequence. So the first thing that I want you to do is I want you to find the 150th term of this sequence. Okay, so what I did was I went through and I found the general form. I noticed that the common difference was 11 going from one term to the next. General form was 11n minus 6 then. Allowed me to find the 150th term, which was 1,644. And then I had to find the sum of 150 terms. So I put that into my sum formula, which you get on your test, by the way, and which led me to the sum of 123,675. All right, so this next one, word problems. We all love word problems. They're the highlight of my day. So what I want you to do now is to go ahead and see if you can try this word problem out. Now remember, we're doing sequences. We're doing arithmetic sequences. So this is just an arithmetic sequence disguised in a word problem. All right, good luck. All right, give yourself a pat on the back if you came up with $10,000. Okay, total prize money there, 10,000. First term was 1,000. The 16th term was 250. I got that by finding the general form and then finding the 16th form and then got the 10 grand by using the sum formula. All right, last question here. A small business sells $10,000 worth of skincare products during its first year. Sounds like 10,000 might be my first term. The owner of the business has set a goal of increasing annual sales by $7,500 each year. So sounds like my common difference is 7,500, and it wants to do it for 9 years. Okay, assuming that this goal is met, find the total sales during the first 10 years this business is in operation. Okay, good luck. All right, did you get $437,500? I think I chose the wrong career path. All right, thanks for watching the video. If you have any questions on your Math Excel assignment, make sure you ask, or if you have any questions in this video that need explained further, feel free to ask me during class. All right, have a great night, evening, morning, not really sure when you're watching this.